So here we look at the importance of database stored procedures. Yeah. The diagram I drew here give you the basic structure, the architecture. Yeah. Here we talk about distributed web applications. Yeah. So in the center, so we have a data center. Then each circle, we represent one location for web servers. Okay, so web server 1, 2, and so on. Yeah. All right. And also we can imagine in different locations, different programming language could be used. Yeah. Different programming language could be used. Yeah. All right. So here you can see the whole system, pretty complicated. Yeah. So then we need to look at the data transmission efficiency, efficient way. Yeah. I need to explain how to make data transmission very efficient. Yeah. All right. Yeah. So I delayed that part, the last slide. So let us work on some relatively simple things first. Yeah. Do some preparation. First, the procedure. So for the database stored procedures, there are 2 formats. So basically, they are functions. Now, when we write functions, then there are 2 types of functions we can write. Yeah. Based on the input and the output. Yeah. All right. So here, the first type we call the procedures. Yeah. The name of the functions we call the procedures. And when you use procedures, no explicit output. So you only do data processing. You take input and do data processing and no output. Yeah. Just like a void functions. Yeah. So that's the procedure type. Then functions. If you want to return output, you use functions. Yeah. So the keywords. Yeah. Function, procedure, function. Yeah. Yeah. So then you can generate output. All right. Properties. Yeah. All right. Yeah. So we define these procedures, functions using SQL statements. Right? Yeah. SQL statements. Okay, yeah. Containing logic, yeah, because in functions we need to use logic, right? If else, that kind of basic control statements. All right. So that part, the definition part, we know it belongs to the metadata part, of the database. Stored and executed by DBMS at the database server. Yeah. So we need to install all these stored procedures in that DBMS. Yeah. Inside, in that DBMS. Yeah. All right. At a database server here. Okay. All right. Then the next property, created in DBMS or application program. In DBMS, we just execute the definition of these procedures or functions. So they are installed. Then in application programs, remember we have programming interfaces, right? Yeah, we can use programming interfaces to send SQL statements to the database server. Yeah? Yeah. So then the database server execute the SQL statements to get these stored procedures installed in the database server. All right? Yeah. Yeah. Then we need to use these stored procedures called in application programs. Yeah. So here in our web servers, yeah, because we need to use stored procedures in these web servers, all the locations. Yeah. So we need to call store the procedures in our application programs. Okay? By sending appropriate SQL commands. Okay? Call procedure name. Procedure, you need to give names, right? Function names. Yeah. Yeah. Just our usual way to develop functions. Yeah. All right. So that's the basic picture here. Yeah. Next slide, I want to show you the general form of declaring stored procedures. Two types. Okay. The first type, procedure type. Okay. So here you can see we use the typical SQL statement. Create procedure, then you need to provide a procedure name. Then input parameters, so input. Then you need to declare local declarations. Variables, right? Local variables, right? Yeah. Here. Then write your procedure body. Okay. The data processing in this procedure body. And then no output, no return data. That's the first type. All right. Then, second type. Yeah. So this one, we just need to add return data. Yeah. On top of this structure, we add a return data. All right. Yeah. Create function name, input. That returns return type. Okay, all right. That local declaration and function definition, the body part. Yeah, see, the structure very simple. Yeah. So then you just follow the, basic SQL syntax. So you write a function definitions. All right, yeah. Okay. Yeah. So very easy to use. Yeah. Next, we need to look at, so what's the benefits when we use stored procedures in our globally distributed web applications? What are the main benefits? Yeah. The main benefits, several benefits, but the most important one, efficiency of data transmission. Yeah. All right, so let me use the last slide to explain. Yeah. All right, circumstances using stored procedures. All right. Typical cases. A database program is needed for several applications. Here you can imagine. Yeah. We know when we write stored procedures, we want to do specific data processing. Yeah. Involving large number of SQL queries. Yeah. Some of the queries could be very complicated. Yeah. In that situation, So then, after we write a database program, here the stored procedure, that program can be used by several applications. Even multiple web applications, if you need to use that particular data processing task, you can call it. Yeah. So no problem. Yeah. All right. Yeah. So that's already some benefit, right? Yeah. Not restricted by any particular application, because it stays in the database server. Any web application, if you can access the database server, you can call it. Yeah. So this is already a benefit. Yeah. The applications could use different programming language. So here we are talking about, so let me draw that, simple diagram again. Yeah, like this. The middle one, a little larger. Yeah, so that's the data center. Okay, all right. And we can imagine many database stored procedures are installed in this data center place. Then two, and so on. Okay, all right. Yeah. Then the question. So here, different locations. People can use different programming languages. Yeah. Yeah. For some special reasons. Yeah. For example, some applications may need to use AI modules, right? Yeah, AI modules. Yeah. So then, to call AI modules, probably Python is a desired programming language. Yeah. And some, Microsoft, right? Some locations, people need to do a lot of data processing using Microsoft tools. So it's better they use Microsoft, .NET, C# programming languages to use Microsoft tools. Yeah. Things like that. So different locations, because they need to do different services. Yeah. People also call the services. And for some of the services, some particular programming languages are better than others. Yeah, that's very common. So there are good reasons people may use different programming languages in this whole big web application. All right. Then we consider reduce duplication effort. This point, benefit, right? The benefit using stored procedure. Let me explain this. Reduce duplication of effort. Yeah. All right. Let's imagine for one particular data processing task, if we do not use our current way, currently we use database stored procedures. Now, so it's here, the central location. All right, let's imagine if we do not use this way, then we can use any programming language to do it, right? Yeah. Java, we can do data processing. PHP, we can do data processing. C#, .NET, we can do data processing, right? Yeah. Python, we can do data processing, right? All right. Yeah. But then, think about, for different programming languages, if you need to write the code for one particular data processing task, you need to write your own version, right? Yeah. If you do not use SQL to write, for Java language, you need to write the Java version. For PHP language, you need to write the PHP version. Then .NET, C# version, and Python version, right? Yeah. So for all those different programming languages, you need to maintain many different versions. Is that duplication of effort? Yeah. Because for the same data processing task, so you need to maintain several different versions. That's not efficient. If you use this way, you use all the procedures, SQL version, you only need to write once, right? Write it once and run it in the database server. Then all other programming languages, you just call the central version, one version, SQL version. Yeah. So then you do not have duplicate effort, right? You only need to maintain one version. Yeah. Think about. So this is important benefit, especially when you need to change something. Think about data processing. Sometimes the business requirements may change, right? You need to change. When you change the logic, sometimes, if you have multiple versions, you need to change effort everywhere, right? Yeah, for all the versions. Yeah. This way, you only need to change at one place. Much more efficient. Yeah. And so this is one important benefit. There is another one. Improve software modularity. Yeah. So here you have one module, SQL database module. Yeah. 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 So that part easy to understand. Yeah. But there is another big benefit. This one is a big benefit. Reduce data transfer and communication cost. Yeah, this is more important. Yeah, let me explain this point, this benefit. Data transfer, communication cost. Yeah. So that means here, let's just focus on the response time. Data processing, you need time. You need execution time for particular data processing work, right? Yeah. Now, let's compare two different ways. SQL way and application program way. Yeah. Because we can use SQL stored procedure to implement data processing. We can also use any other programming languages we can implement data processing. Let's compare efficiency. Let's compare efficiency on data transfer, communication cost. Yeah. Yeah. The execution time. Yeah. These two ways. Right. Yeah. Yeah. So here, look at the main point here. So first I talk about the less efficient way. Less efficient way. That's the application program. So we do in our web servers. Less efficient way. Yeah. That less efficient way, think about when we implement one particular data processing task. One particular data processing task. Right? We need to do a list of SQL queries, right? Yeah. Usually, we need to do a list of SQL queries. All right. When you do SQL queries, you need to send a SQL command to the database server, right? Yeah. You need to send SQL query statement to the remote database. It takes time, right? Yeah. Yeah. So data transfer through the internet. Okay. And database server needs to return the query result. Send it back to you. Query result. Okay. That also takes time, right? All right. Back and forth. All right. And because you have a list of SQL queries, you need to do queries, results many times, right? Yeah. Many times. Yeah. And every time when you do the queries, because each query represents some intermediate result, right? Intermediate. Yeah. Yeah. Because it's not a final result. Yeah. Because you need to, after you receive the returned data, you need to work on it. You need to use your special business logic to work on the returned data to produce the final result. So what do you get? What do you get? That's the intermediate data. You get an intermediate data, all right? Yeah. Think about, for a list of SQL queries, you need to do data transfer for the intermediate data back and forth many times. Does it take a lot of time through internet? It takes time. Okay? Yeah. Yeah. So this is a less efficient way. Okay. Less efficient way, right? Yeah. You need to use a lot of internet traffic. Yeah. It takes time to do the processing, data processing in that way. Next, let's look at a more efficient way. Yeah. The basic idea, we want to reduce the internet traffic, data transfer for intermediate data. Intermediate data, we want to save that part. How to save? Yeah. The idea is very simple. All right. Because we call store the procedure in our database server, then all the data processing query works all executed in the same location. One location. One location, all the intermediate data processed in same location. No data traffic needed, right? Through internet. You don't need to send through internet the intermediate data. Yeah? Because all the intermediate data stays in the same location. Yeah. You only need to send a final processing data back to the requested server, right? Yeah. You only send the final result. So you save a lot of intermediate data traffic. Okay? So in that way, we can say that's another big benefit. Yeah. Two big, one is this, reduce duplication of cost, effort. Another is this reduce data transfer, communication cost. Yeah. These two. Yeah. In that situation, in that special situation. Yeah. All right. Yeah. So with this understanding, so later, so if you are in this situation, so the data saving could be very significant. Yeah. The response time should be much faster. Yeah. using this way. All right, yeah. So that's the, another benefit, yeah. So we already, these two big one, okay. Yeah, but there is another one, also very nice benefit. Access data without giving out too much permission. Yeah. We know for a large database, there are many tables. Some of the tables may store sensitive data. Then, for higher level sensitive data, not everyone can access, right? Yeah, because in DBMS we can set privileges for different users. Some users, you do not have the privileges to access certain tables. For some users, you have the privileges to access certain tables. Yeah, that's very common for a big database. All right. In that situation, this stored procedure has another important usage for that situation without giving out much permission, the privilege. Okay, some programmers, they do not have the permission for one particular table, but they need to use the data processing involving that table. Yeah, so this stored procedure provides a way to do it. Yeah. All right, so what's the way? Some users may not have access to certain tables. Yeah. All right. Then, through stored procedures, so you access those tables through stored procedures. All right. Yeah. These users may need some aggregate information. Yeah. So these users, they do not access those tables directly. Okay. Yeah. Indirectly, through stored procedure, but the stored procedure only uses the aggregate information. Okay? Sum, average, count, that kind of aggregate information. Then you can do those things in stored procedure. Yeah. Yeah. But these users, they just call the stored procedures to access, to use aggregate information from the tables that they do not have permission to access directly. So that's another nice benefit. Okay? Yeah. Yeah. These two are the most important. Yeah. All right. Yeah. So that's, from this discussion, you can see, very useful. Yeah. Yeah. Although it's an old technology. Yeah. This technology is very old. But it's still very useful. Yeah. All right. The SQL is very old technology, right? Yeah, the SQL, very old technology. But currently it's still very useful because for data science, a lot of applications, they need to use data quite a lot. Then they need to use SQLs a lot. So still very important. Yeah. All right, so we finish part D. Yeah. Next, I want to jump back. So we have, remember, 2 case studies. I did a second one. Now I want to go back to the first case study to talk about main algorithm ideas for that Google search engine. Yeah. The pre-processing, I want to emphasize the importance of pre-processing idea. Yeah. Derived data, we can use derived data to speed up the search performance. Yeah. Here, let me explain the details of this idea. All right. Yeah. So this ones we did last time, a case study. So today we use another slide to explain our first case study. All right. The pre-processing idea is very important. All right. All right. Yeah. So we're familiar with the problem description, right? Yeah. So problem description. Yeah. All right. So here, let me just describe the problem we need to solve. Yeah. To do. Okay. Yeah. Given a list of keywords. Keywords-based search. Okay, all right. Return. Web pages. Containing those keywords. Yeah, so that's the problem. Okay, yeah. All right. The description, very simple. Yeah. But you can think about how much data processing work we need to do here. Yeah. And in this application, the response time very efficient. The users do not want to wait too long. Yeah. The user, so here, the typical expectation from the users, the response time should be less than 1 second. Less than 1 second. Yeah. As the user's normal expectation. Yeah. But the question, how can you do that fast? Because the web pages in the world, there are a large number of web pages in the world. How can you do the, keywords-based search on large number of web pages in that short period of time? Yeah. Pre-processing. Yeah. All right. Yeah. Because in our previous case study, you learned pre-processing. Yeah. So here you have some idea. Yeah. So this is the second time we use this pre-processing idea. Yeah. All right. So let's look at what kind of data processing work we can do. We can do our preparation ahead of time. Okay. Yeah. For the pre-processing, you do not need to get the user's requests. So you can do the data processing without using the user's requests. So, yeah. All right. So let's look at the pre-processing step. First, if you do keywords-based search directly, it is very slow. Keywords-based search directly on each page, it is very slow. Why? So given a web page, one web page. So here let's just consider one keyword. One keyword, single keyword. All right. Then you need to go through the whole page, right? Line by line, whole page to match. There is some algorithm. Here we assume there is some efficient algorithm, but you need to go through all the lines from beginning to end to match. Okay? If it contains. All right. So that search, not very fast. All right. So here, data search. Let me talk about some basics of data search. Data search. Okay. All right. Data search here, let's consider two different types. Two different types of data. One is numeric data. Another is string data. Typically, these two types. String data, let's look at this. Consider the string data. Keywords-based search, that's the string data, right? Yeah. String data, when you do the search, you need to match character by character, right? One string contains a list of characters. And when you match, you need to first try to match the first character. After you match first character, then you try to match second, and so on. Okay? Yeah. So the algorithm based on matching all the characters in that string. Yeah. Yeah. And a numeric-based search, you do not need to match digit by digit, right? Because numeric value, you can compare two numbers directly, match or not immediately. So comparing these two different data types, numeric data operation, search operation, faster than string data search, slower. So that's one basic fact in data search. But our keywords-based search, they are the slower string data search. Okay? Yeah. So then, this time we want to make it faster. All right. One idea is, can we convert string data search to numeric data search to make it faster? Yeah. So that's one idea. All right. Yeah. So I put this question aside. So let's talk about other things. All right. Pre-processing here. All right. Pre-processing, people need to do large amount of work. Yeah. So here the work is the processing work, typical processing work. What kind of processing work? All right, very simple. Keywords. Yeah. web pages. Right? 2 columns. The first column, keywords. The second column, web pages. Okay? All right. Yeah. List KW1, KW2, KW3, and so on. Okay? A list of keywords. And these keywords, can we give them a numeric ID? Each keyword, we can use a numeric ID to represent it. Yeah, like 1, 2, 3. Yeah. 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 Later, we will call primary key. Primary key, okay, the concept. Yeah. Here, numeric ID, unique, primary key, okay, all right. Each keyword. Yeah. Then, web pages, you have a list of web pages, okay, yeah. All right, yeah. Web pages 1, pages 2, okay. X, okay, all right. Then, you can also have a numeric ID, right? Primary key, okay, yeah. All right. Then later, you can use their numeric ID to refer these, string values, right? Yeah, string values. Yeah. Web pages, you can use URLs, right? Yeah. Because each web pages, when you store the locations of the web pages, you use URLs. Yeah. Through those URLs, you can get the content of the page. Yeah. So you visit the server, yeah, you get the content of the page. Then you do stream-based search. Yeah. All right. Then the processing work. Basically, you need to do mapping, right? Yeah. Keyword 1 appears in some pages, but keyword 1 may appear in multiple pages, right? So each keyword appears in many pages. Yeah. All right. So so here, what do you need to do? The basic processing work. You need to do mapping. This kind of mapping, data processing, and this step people call indexing. Indexing work. Yeah. And in order to get the mapping information, yeah. So here, the derived data. Let me talk about because the result is you generate derived data. Derived. So what's the derived data? Yeah. A new table, new mapping table. Yeah. Okay, a mapping table. Yeah. Derived data. Okay, not original data. So new mapping table. All right. Yeah. So the mapping table is very simple. The structure is very simple. Yeah. Let me describe the basic structure of the mapping table. Okay? All right. All right. Like this. All right. The first column, numeric ID. Okay? The first column, ID, primary key. Okay? Primary key. Okay? 1, 2, 3, and so on. Okay? Yeah. Yeah. Column number. Okay, column number. All right. Then the second column, keyword ID. Keyword ID. Okay? Yeah, keyword ID. This part. Okay? Yeah. Keyword ID. KWID. Yeah. KWID. All right? Yeah. The third column, web page ID. Okay? Numeric number. Web page ID. Also numerical value. Okay? All right. 5, 1, 2, 6, 10, 100, 11, things like that. Okay? Then, in that way, you generate a mapping table. Okay? Mapping table information between keyword ID and web page URL ID. Okay? All right? Yeah. Yeah. So this is the derived data. Derived data. Okay? Yeah. When you do pre-processing, pre-processing, here, a little more information about the pre-processing. Some special type of small programs called spiders, right? Yeah. So they send spiders, so the small programs send out everywhere in the world, crawling on the web. Remember the web? So spiders on web. So those special programs, spiders programs, sending out work day and night, all the time, large number of servers, we can do this kind of processing. So visit all the web pages in the whole world. So then visit there, then do the keyword-based search. After that, generate new information, fill in this mapping table. Okay? Yeah. Keep doing things like this all the time. Okay? Yeah. Yeah. Using a large amount of computing power. Okay? Yeah. You can imagine millions of servers to do that. How about that? Okay? Using millions of the servers in the world. So doing, updating the keywords and the web pages mapping all the time. Yeah. Yeah. Because you need to keep updating, right? Yeah. Keep updating. Yeah. All right. But your processing result, this derived data. Okay? All right. Here you can see, without this pre-processing, you cannot get very fast response time. Now, let's look at why our users, we as users, we can enjoy very fast performance results. Yeah. All right. Now, this time we're ready. We connect to our search experience, basic search experience. We type a list of keywords here. So now we are at users submit keyword requests. Okay, so here, users send the data keywords. Keywords request to the search engine. Then, after that, after the server receives list of keywords. Oh, another thing I forgot to mention here, when we do the search on this table, we do numeric search, right? All the numbers. Numeric search very fast, right? Yeah. So that's another. So we use this basic effect. We convert stream. So stream-based search we do in pre-processing. Okay, this indexing step we do stream-based search. Then, after we get derived data, then our new table containing numeric values, so all numeric values. And then when we do the final search, we do it in the table with numeric data search. So much faster than the string data search. Yeah, so that's another improvement. All right. Then, so the list of keywords. First, we can go to this table. Go to the table, we can get a list of IDs, right? Yeah. Keywords. So first we go to the keyword table. Keyword table to get a list of IDs, numeric values. Okay. All right. After we get a list of numeric value, the IDs, then we can go to this derived table to, all right, now, this step also important, this step. Using this list of IDs, because this table very large, right? Think about it. This table is huge. Yeah, because this mapping table is huge. Okay? Yeah. And when you, even the numeric data, if you do it in a huge table, still it takes quite some time, right? Yeah, still takes time. Yeah. All right. So then, here we need to do another thing to improve our users' experience. All right. When we do the search, first, we do aggregate information. We count, okay? We count the number of pages that contain the keywords. That's aggregate information, right? Counting number, okay? Counting number. Okay. So we do not get that particular list. So we need to get a counting number. Yeah. So that operation relatively faster. Because you only need a number, okay? Yeah. Yeah. 1 million pages, yeah. Large number containing this keyword. So you send this aggregate information to your users, let users see, oh, yeah, so this search, you get this many pages containing your keywords. Yeah. So you get that number. That is pretty fast. Second, then the page information. Yeah. You need to return the page information, right? Yeah. But the Google search engine, they use some trick to improve the user's experience. So that one, they do not need to return 1 million pages at the same time, right? So they do pagination. So they just return the first page. That's enough, right? So your search result, you get the first page. First page, the number of links, not too many, right? So relatively small number of pages. Yeah. So you only need to return matching for the first page. That search pretty fast, right? Yeah. Yeah. Because the number of links, relatively small number, okay? 10 something to up to 20, right? Less than 20, yeah. More than 10, for example. That number. To get that first page information, that is very fast, right? Yeah. 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 But actually, the derived table, the structure of the derived table actually a little more complicated than this one. Yeah. Because, remember, there is a rating question, right? Yeah. So another column containing the rating weight. Rating, you can use a numeric value. The larger rating number means more important, right? Yeah. Yeah. So you search based on that rating number. Yeah. Yeah. All right. So the first page, based on their rating numbers, they should be the most important pages containing this keyword. Okay? Yeah. But then, how to get that rating number? Yeah. So that's the, those two founders when they did their PhD dissertation in Stanford, so they came up with the idea, this rating algorithm. Rating based on the links from other pages. Yeah. So how do they make one particular web page important containing one particular keyword? Yeah. So if this page is referred by many other web pages, more references, yeah, they count that number. So they create a criteria. If one page is referred by many external, not internal, okay? If the same website, you refer this page, doesn't count. So they only count the references from different web servers. Different web servers, okay? Why those other servers, other web pages want to refer your particular page? Because they treat the information provided by this page more important. So they based on that criteria. Okay? So that's their PhD dissertation in Stanford University. Yeah. All right. So based on that, so they create a rating column. Okay? Yeah. So another column, rating column. Yeah. And when they do the search, on the first page, they sort the search result based on the weighting number in descending order, right? Descending order. Descending order, the higher the rating number, it appears at the top. But they only take one page of it. One page of it. Okay. Small number of search results. Okay? Yeah. When you go to the next page, second page result. Also very fast, yeah, based on the rating numbers. See, that's typically the main ideas of the Google search engine. Okay? Not very complicated, but you need a lot of computing power to do this kind of pre-processing, store large amount of data. Okay, a lot of details, well, but the main ideas, yeah, so you can see from this slide. Okay, yeah. So now I just make some final summary. Yeah. Yeah. Now we have two case studies, okay, based on pre-processing, and the pre-processing for both case studies generated derived data, yeah, to help us speed up our main search requests, right? Yeah, key search requests. Yeah. Yeah. All right. In this, the pre-processing, yeah, actually, our second case study, the pre-processing part, is a little more than the first one. Yeah. First one, pre-processing, we just create that mapping table, right? Yeah, mapping table. That's pretty simple. Although a lot of work you need to do. Yeah. Yeah. But our second case study, we do a little more than simple mapping. Yeah. We need to do localization. Okay. We need to divide the whole Earth into smaller regions, but those smaller regions are easy to control. Okay? Think about if we use the zip code regions, because the shape of each zip code could be very complicated, right? The shape. Yeah. So it's not easy to control zip code regions, zip code based regions. But then if we use the grid, okay, we divide the Earth using smaller square regions. Now, the shape is a square. Square shape, very easy to control, right? Yeah. Given the coordinates of any point, yeah, people call it geolocation, okay? Yeah, geology, geolocation, yeah. So given the, longitude, latitude, that information, you can find the location of the one square region immediately. Yeah. All right. Then when you do pre-processing, this time you create a mapping. One square we have an ID, right? Each square we use one ID to identify it. So one square is mapped to a list of triangles, that kind of mapping. Yeah. Yeah. So here you can see both case studies, the main derived data, that's the mapping data. Mapping between two types of objects. Two types of objects. You need to create a mapping table. Okay? Yeah. Yeah. The Google Map one, right? Yeah. Each square block, yeah. So that the square unit block is mapped to a list of triangles. Yeah, that information we need. Okay? All right. Yeah. So after that, when we do the search, as soon as we find which square block contains the given point, then we retrieve that list of triangles, then we do the search in that list. Yeah. So it reduces our search range significantly from 1 million to 10 something. Okay? Yeah. You do not need to search the whole 1 million triangles. You only need to search in that much shorter list, 10 something triangles. Very fast. Yeah. All right. So these two case studies, I hope after you learn, although this is a database course, yeah. But when you need to use your business data, you also need to connect to the real world application, right? Yeah. So we're not separated from the real world applications. Actually, when we connect to the real world applications, then we can understand the importance of our data services better, right? Yeah. Yeah. All right. I hope these two case studies, so you can at least give you some impression. Later, when you need to do something, you need some very fast data service operations. Yeah. But if you do directly, very time consuming, you need to think about data pre-processing. Okay? How to do pre-processing? Yeah, mapping. Okay? You need to find a way to do the mapping between two lists of objects. Okay? Two lists of objects. Okay? All right. Yeah. So last thing, as summary. Yeah. Case study 1. These two lists of objects. The first list, a list of keywords. Second list, a list of URLs. Then do the mapping between these two lists of objects. Case study 2. The first list, a list of unit squares, okay? Unit square regions, okay? The first list. Second list, a list of triangles, list of lists, okay? Because each object is a list of triangle IDs, right? Yeah. Each object, the object is one list of triangle IDs. Okay? So list of lists, object, appropriate objects. Okay? Yeah. Then you try to get mapping information to speed up your operations. Okay? Yeah. All right. Yeah. So let me stop here. So we complete module 2. Yeah. So next time, Thursday we start module 3. That's the SQL query. Yeah. The whole module 3 is about the SQL queries. Yeah. Basic knowledge. Yeah.
So for the 10-gram puzzle, all of them will be triangles?
Triangle, yeah.
All the shapes in the 10-gram puzzle are triangles?
Square, one square, one parallelogram, right? Yeah. Oh, yeah. Yeah. So that information, parallelogram, that information you can find from W3 schools. There is one tutorial page. Yeah. Yeah. But here, because you mentioned that 10-gram thing, one thing I would like to let you know, for parallelogram, yeah, only parallelogram. Other shapes, fine. Parallelogram is special. When you do rotation, you get a distortion, very messy. So for that parallelogram, we do not do rotation, okay? Forget it. We do not need to do rotation on parallelogram because the shape could be changed. Yeah, so we don't want to do that. Parallelogram, you only move positions, no rotation, okay? To simplify a little bit. Otherwise, it could be complicated.